Hi, thanks to the organizing committee of the conference for giving me this opportunity to present some insight related to more than 10 years experience about mine waste valorization. I have also to thank my colleague Dr. Anita Barbakar Fox for the invitation. It's for me today a great pleasure to present some of the fruit of collaboration between three institutions: University of Quebec, where I'm affected to, and two universities in Morocco, UM6P Bangrir and Qadi Ayad in Marrakesh. I have also to acknowledge my collaborators, mainly Dr. Taha, Haku, Benarshid and Amrani. The title of my presentation is Mine Waste as Secondary Raw Material in the Framework of Mining Circular Economy. I will talk about legislation and applicability through some example in respect of the duration I have. Mine operators all around the world are still suffering from the negative image, which is the consequence of the important environmental liabilities, which in turn make difficult societal acceptance, as you may know. What also still the practice is that mine exploitations still follow the linear industrial pattern, which consists of extracting limited ore resources and generate high volume of solid waste. This is what qualified as take, make, and dispose. So, as many industries, the mine must change their paradigm to more ecological industry, more circular economy with more valorization. That could be qualified as make, use, and recycle. In this slide, we have the two diagrams illustrating this change of paradigm that the mining industry must adopt. At the left, the linear one that still corresponds to the majority of mines, and at the right you have the circular pattern that require to consider the resources as limited and must minimize the volume of waste to be stored at the surface of mine site, tending to what we call zero waste objective. So here another illustration. What we can see in this figure is how mine waste could be managed for more reuse at the mine site and the neighboring smelters in the case of polymetallic or precious mine, hard rock mine. This led at the end to less disturbed footprint and easier site reclamation. Many terms and definitions exist to qualify these new trends. I like the title of this session, Reframing of Resources. We have also reuse, reutilization, recycling, valorization of course, reprocessing, repurposing, etc. All means the transformation of wasted material to byproduct or secondary resources when possible, beneficiating from the valuable element that could be occurring. Other consequences are the reduction of the volume of waste to be stored in the surface of mine site, and the reduction of a footprint, and finally trend to a cleaner mine and zero waste concept. Well, how to do that? There are at least four main criteria: technical, legal, economical, and the fourth is about sustainable development. So, the first one consists of having the necessary research, academic research, technology development, demonstrators, guidelines, and so on. In the second one, we have to dispose of legislation, the needed legislation. And in the third one, the mine industry conviction and adhesion is important. They must consider this aspect as being a part of their mine life cycle. And at the end, population acceptance is very important. It is very influenced by the first criteria. So, what's about legislation? Here I will try to show you all the legislative arsenal in the Quebec province in Canada that's still under the federal Canadian legislation for these aspects. So first we have to talk about the mining law, which contain at least two main aspects related to mining and environment. The first one is Section 3 about protection, rehabilitation, and reclamation measures, and Section 4 about optimal recovery of mineral resources. We have also what is called Directive 19 for the mine industry in Quebec. It helps in the selection of environmental guidelines and basic requirements for the different types of mining activities in order to prevent the deterioration of the environment. The directive also provides stakeholders in the mining sector with the necessary information for the development of the impacts or environmental repercussions study prior to a request for certificate of authorization for a new project or on request certificate of authorization for the modification of an existing project. All these documents I'm presenting are available for downloading, but in French only. What's relatively new is the annual duties for all deposition of mining waste in accumulation area. So since January 2014, each ton of mining waste deposited on the surface in the accumulation area is subjected to a tax, even temporary, and even the material could be considered as potential ore. The Ministry of Environment wants to encourage mining companies to reduce or to recover the significant amount of mine waste deposited in accumulation area. The duties are dictated also to participate to the effort to reduce the environmental footprint of mining activities and promote the social acceptability of mining projects. The Ministry of Environment launched also an explicative guide in 2016 to fix the annual fees applicable to mine operators. The fixed annual fees evaluated every 1st January and the variable annual fees depending on the type of contaminant within the waste. So here you have the document which is called Guideline for the Valorization of Mine Waste. What account for valorization within mine waste and outside of mine site, like for construction, civil engineering. And there are three main categories for in situ valorization. First one, mine site, roads, surface embankment, dams. The second one is underground and open pit backfilling. And the third one consists of the cover construction for reclamation. Another document for the classification of mine waste to be valorized as resources out of mine site for civil engineering mainly. The document is called Guide to the Valorization of Non-Hazardous Inorganic Residual Material from industrial source as construction material. But acceptance remains important issue. Then we have a decision diagram for a multiple level of parameters measurement. The first step of the flow chart consists of the classification of the waste rock sample, if it is non-hazardous or hazardous material, using the chemistry and the metal analysis. The second step is for organic matter content, and the third one is sulfide content regarding the acid generating potential. This allows to classify the material as possibly reusable for category 3, which include the concrete manufacture. Then many steps were described in the document, here illustrated by the succession of these figures, and consisting of, on one hand, the comparison of the composition of the waste rock to the criterion A of Directive 19, which allow to classify the waste rock into category 1 directly if validated. If not, in the case of waste rock with higher sulfide content, and depending on the particle size distribution, waste rock are classified as category 3, and then we could also, following a succession of leaching tests regarding the regulation criteria, classify these waste rock even into the category 1 or 2, and at least in category 3. So for application and as examples, let's see the case of some Abitibian mine, precious metals mine. These mines are characterized by low grade and high tonnage, usually exploited using open pit mining. We have, as we've seen, a good legislative arsenal, and we are here in the presence of high potential and opportunities. The first example is the historical Sigma mine near Val-d'Or in Abitibi. The mine was in operation since many decades underground, then more recently through open pit mining. Now the mine operation is suspended. Millions of tons of waste rocks have been produced that are non-potentially acid generating. On the other hand, Fournier, a leading company and the most important supplier of all construction material in north of Quebec, took this opportunity with the owner of Sigma mine. They bought all rights to exploit these waste rock dams around Sigma mine, and they are using them presently as construction material for many activities, for road construction, concrete manufacture, and with a frequent, of course, control of quality in terms of potential of acid generating and leaching. The bypass you are seeing here of the Trans-Canadian road is also made of this waste rock. The second case, another gold mine called Canadian Malartic Mine, which is still operating presently and representing one of the biggest North American gold mine. It generates 120,000 tons per day of waste rock containing 1 to 5% of pyrite. The waste rock are also classified as uncertain in terms of acid generating potential. For valorization purposes, these waste rocks were sampled carefully through a robust protocol to have representative sample from the pit, then submitted to analysis for the classification purposes as we seen before. So first, the waste rock must be checked for their toxicity based on their chemistry. If there is no risk of toxicity, the waste rock must be checked for their organic matter content, and if no organic matter content, the waste must be checked for their sulfur as sulfide content. So if too much low, under 0.2%, waste rock sample are guaranteed as category 3 and could belong to more interesting classes as we seen in the previous slides. If the sulfur content is higher than 0.2, waste rock must be submitted to acid generating potential testing, usually done using the modified acid-base accounting more widely used in Quebec, or the NAC testing. Then if positive results obtained, the waste rock could be classified as category 3 depending on the particle size distribution. If not, the waste rock cannot be valorized. Here we could think about reprocessing. That's mean removing the fine and reactive fraction. This slide presents the chemical analysis of the waste rocks. In the table here we have in the left, and as we see, the sulfur content is higher than 0.2, so acid generating potential determination is necessary. We could see also the carbon content, which is higher than 1% and only in the form of carbonates, as we see here in the XRD mineralogy. This table presents the results of the acid generating potential determination using the acid-base accounting test, and classification was done according to Directive 19. As we could see, the mine waste rocks are non-acid generating. Here in this table we have the leaching behavior results according to the TCLP test. Waste rock element release concentration are presented here in the right of the table. So only some elements concentration are over the regulation in terms of criterion C, but all the other concentration are below the criterion C. For the manufacture of concrete, some tests are necessary, like mechanical strength. We are noticing here in this figure that the UCS values are comparable to the reference concrete made of natural aggregate. We could also consider waste rock as natural aggregate with more than 38 megapascal at 56 days of curing. Concrete samples were also submitted to monolithic leaching tests only to verify if some toxicity is detectable. So as could be easily seen in the figure here, all measured parameters are under the regulation in terms of drinking waters. As a brief conclusion, mining waste must be managed and considered in different ways. In disruption of the conventional practices, they have to be evaluated accurately through adapted guidelines and classified then for different valorization purposes. We could also think about reprocessing not only for beneficiation purposes but also for decontamination. Once classified, the product have to be evaluated technically, economically, and environmentally as end-use product, eco-product. The population acceptability must be there also. This ends my presentation, so thank you, and it will be my pleasure to answer if there is any question.